everybody. My name's Aiden, and I'm back with AP Physics 1, Unit 3 review, circular motion. So, one of the biggest concepts, maybe the biggest concept in this unit is UCM, or uniform circular motion. And this is just perfect circular motion where the tangential velocity and centripetal acceleration do not change in magnitude. The direction will always change. It's important to understand that they are not constant under UCM, but the magnitude will not change. So the tangential speed will not change. The velocity will change because the direction is going to change. So instead of always being, pointing this way, sometimes it's going to point that way, other times it'll point that way, like so on. And then centripetal acceleration always points towards the center of the circle. That is the most important part with centripetal acceleration. That's what it means. But you can calculate centripetal acceleration with A equals v squared, which is this tangential velocity, over r. And then you can calculate the centripetal force by just multiplying this by the mass of the object. So F equals ma, or in this case, F equals m v squared over r. So, and another important thing to understand is that centripetal force isn't like an actual force. It's just what we call the force that keeps an object going in circular motion. So a big example is just like a moon orbiting a planet. It has a centripetal force, but the force itself is the force due to gravity. Or you can swing something with a string, has a centripetal force, but it's actually just the force due to tension. That's what keeps it there. So another big concept is the force of gravity on other planets. This equation is on your formula sheet. And it's just f of g. This is how you calculate it. With other planets, there will be questions on the test that will use this equation. F equals g times one mass times another mass over radius squared. And g is a constant that's on your formula sheet. This is the exact number they have on your formula sheet. And it has these crazy units here. But m, the big M, or in some cases it'll be m planet, m subplanet, I mean, is just the mass of the planet or whatever the bigger object is. Lowercase m is the mass of the moon or the smaller orbiting object. And then, of course, r is the radius just between the two masses. So, during the orbit. So, acceleration due to gravity can be calculated using the same equation, except you're dividing by, you use the same thing, but you divide by m, so it just cancels this out. So it'll just look like that. So yeah, this is a very important equation to understand. You don't have to memorize it or anything, but it's important to understand because it's on your formula sheet. So radians, this is an important concept, not really for this unit too much, but you just need to understand it with circles. A circle is 360 degrees or 2 pi radians. So the 1 period for rotation, it's just important to understand that one rotation for this, or 1 period, is just one circle. And that'll be important in the simple harmonic motion unit, or in torque. You'll understand angular velocity. That'll be an important thing to learn in Unit 7. So the perimeter of a circle is 2 pi r. So if you know the radius of a circle, then you can find the length or perimeter of the circle. And if you know the perimeter or length, you can find the radius. So that's all. And you won't really be using area. So, circular motion example problem 1. If an object has mass m, velocity v, and moves in a circle with radius r, what happens to the centripetal acceleration on an object when the velocity is doubled? So since acceleration equals velocity squared over r, if v is replaced with 2v, you have a equals, in parentheses, 2v squared over r. So that'll actually be 4v squared over r. And this equation right here is 4 times this equation. So the centripetal acceleration will be quadrupled. So this is a pretty easy question on just the concepts. So circular motion example problem, this is the second one. So a car of mass 1,500 kilograms goes in a circle of radius 1 kilometer at a velocity of 250 kilometers per hour. Calculate the centripetal force a driver of mass 100 kilograms would experience in the car. So you have to first convert the speed here into the scientific notation units. So 250 kilometers per hour, you just convert it here, and you get 69.4 meters per second. So you can set up the equation with F equals ma, or F equals mv squared over r. You can plug in the numbers right here, which 100 for mass times, the velocity squared divided by the radius, and you get 482 newtons for the centripetal force. And it's important to understand here Some information they give you may be useless, like this car of mass 1,500 kilograms. You're talking about the driver, so that doesn't actually matter. And so it's important to keep that in mind when solving questions.